Good evening, everyone. Hope I'm audible to everyone. I welcome everyone to the 10th session of this training program. Today's training will be facilitated by Mr. Chandramohan on topic piping supports. I request everyone to mute your mic and turn off your video. I request Mr. Chandramohan to take forward the session.
Thank you, madam. Good evening to all and welcome you all. Hope I'm audible. Okay.
Yes, you are audible.
Okay. Today we are going to see the training topic piping supports. Last week we have seen about the piping component and valves as a part 1 and part 2. After that we have seen piping engineering drawings as a part 1 and part 2. Today we are going to see about the piping supports. Okay. So introduction to pipe support. What is a piping support? A pipe support is a designed element that transfers the load from a pipe to the supporting structures. What are all the load it includes? It includes the weight of the pipe, that means self weight, the dead weight of the pipe, whether it may be a carbon steel or stainless steel or plastic pipes, and then the content that the pipe carries. Content means the fluid which is carried by the pipe. Maybe it may be a vapor phase or maybe a liquid one. The content which carries the pipe that carries, and the pipe fittings attached to the pipe. What are all the pipe fittings we have seen already? It may be a elbow, a equality, unequality, reducers, and even valves that are all considered as the load of the pipe. And the pipe covering such an insulations. Insulation also is the main load of the pipe, because if it is 1 or 2 meter, it is not an issue. If it is kilometer wise, if insulated, we are insulating the pipe, it is also considerably a bigger load on the pipe. The 4 main functions of the pipe support are: the pipe support not only load the pipe, but it also to anchor the pipe, to guide the pipelines, to absorb any sudden shock from the pipelines, and also support a load from the pipe. So these are the 4 main functions of the pipe support. And then pipe support, which we are using in high or low temperature applications, may contain or may not contain the insulation materials. Even if it is a low temperature, even if it is low temperature service, there may be not insulation, will not be insulation. If it is in a high temperature, there will be insulation. That and all we need to consider while designing a pipe support. And then primary and secondary loads. These are the 2 types of load in a piping system. So why the pipe support is required? To keep the pipe stress within the acceptable limits and to prevent the leakage from the joints due to vibration or uneven settlements. That prevent leakage from the joints due to vibration means if the pipeline is connected to any rotary equipment like pumps, compressor, blowers, fans, gearbox, anything, if it is connected, it should prevent the leakage. We should provide the proper support, then we can prevent the leakage from the joint. And then prevent excessive thrust and movements connected to the equipment. And then maintain the good thermal flexibility in a pipeline and keep pipeline in its original position. Position means initially we have laid the pipeline in one set of line. The piping support only keep the pipe in its original position to prevent the sagging and the distortion. So these are all the functions of piping support. As earlier we have seen, there is a primary and secondary load in the piping system. So first we are going to see the primary load. These are the typically steady or constant sustained loads of types of load, such as internal fluid pressure, external pressure, and gravitational force acting on the pipe, such as the weight of the pipe and the fluid, and forces due to the relief or blow down pressure waves due to water hammering or steam hammering. These are all the primary load. So first we will see the primary load. In that primary load, there will be 2 types of loads. as we see here, the sustained load, another one is occasional loads. Sustained load means it is a constant load. It will be always available on the pipe, like internal and external pressure. So external pressure is atmospheric pressure. It is not going to vary. It is always constant one. And the internal pressure is whenever the piping system is in alive, whenever it carries the fluid, this pressure also will be a constant throughout the operation, and external pressure is also constant. Second one is dead weight. Dead weight means nothing but self weight of the pipe, that is including of piping its own weight. We will say pipe in a kg per meter. If it is 1 inch size pipe means, based on the thickness of the pipe, it will vary per kg per meter, how much kg to be. Same like that. That is the dead weight, including the fittings, valves, and the insulation. These are all the constant weights which will not vary towards the operation. This is called sustained loads. On the other hand, other type of load is occasional loads. Occasional load means wind load, seismic load, water hammering, steam hammering, and safety valve discharge. Wind load means sometimes the wind will be normal, sometimes it will be abnormal. So that kind of load will be act on the pipe. So those load will be taken from the pipe support. So while designing the pipe support, we need to consider the wind load also, because these two, internal and external pressure and the dead weight, these are all obviously we will consider. But while designing the piping support, we have to consider this wind load also according to the elevation of the where we are going to install the pipe. And the second thing is, in occasional load is seismic load. Seismic load is nothing but the other factors caused by the nature, like earthquake, some other any shocks, anything is comes under the seismic load. That will be also very depend upon the where it is located. Location to location, country to country, it will vary. And then water hammering, steam hammering, both are quite similar. Water hammering is happen, you may already heard about this water hammering. Whenever there is a sudden stoppage or sudden flow in a pipe, it will cause a sudden shock. That is called water hammering. Sometimes it may create a noise also inside the pipe. Those kind of shock will be have to taken care by the piping support. And then steam hammering, as you know, the steam condenses, there will be a partial vacuum will be created. Those kind of shock also has to be taken care by the piping support. And the last one is safety valve discharge. Safety valve discharge is when in a length piping system, there will be a pressure safety valve. Whenever the pressure increases, sometimes whenever the pressure exceeding the operating pressure, based on the safety valve pop-up pressure, it will pop up. So whenever it pop up, it will create the back pressure to the piping. So that also need to be considered while designing the piping support. These are all the primary load. And the second one is secondary load. Secondary load is also caused, but it is there is some due to displacement, there will be a secondary load. What are all the displacement? I mean, secondary load means load due to thermal expansion of the pipe and load due to thermal movement of the pipe. Whenever there is a liquid flow or a fluid flow, there will be some expansion or contraction will happen. Whenever you start the plant, there will be some expansion. Whenever you stop the plant, shut down the plant, there will be some contraction if it is a high temperature means. So those kind of load will comes under the secondary load. For example, secondary loads may often cyclic, also not cyclic. For example, a load due to tank settlement is not cyclic. So whenever if you construct a new tank and you are connecting your pump discharge to that tank, so initially that is the first time you're going to commission the tank, means whenever you start to fill the tank, the tank may get settled. That means going settled on the foundation. That is not a cyclic load. Once it will happen means after that there will not be any changes in the tank settlement. Those kind of load is called not cyclic. A cyclic load means whenever you shut down and startup is happening, whenever a fresh startup and a shutdown is happening, the pipe is subjected to a cycle of hot and cold fluid. This is called cyclic load. So these are all the two types of load we have seen under the secondary load. First, we have seen the types of common load, primary and secondary. Under primary, we have seen different types of load subcategories. This is the piping support general classifications. I want to show here. The right side one picture is there. This is a permanent structure, and the bottom one is a we call as it is secondary structure, secondary support, and the pipe and the support which is connected directly to on the pipe, it is called the primary support. So here we will see, based on the attachment of support to the pipes, there are two types of support. One is primary support and the second one is secondary support. Like primary load and secondary load, support also we categorize into two support, primary support and secondary support. Primary support, these types of supports are directly clamped or welded for their resting. For example, shoe, a saddle, pipe hanger, wear pad, trunnion. These are all the types of support which we are going to see in upcoming slides. Just for information, you just note down what is primary support. Whatever the support is directly clamped or welded to the pipe material itself, this is called primary support. And the secondary support is, these are the types of support which is not directly connected to the pipe but connected to the civil foundation or structural members. For example, here you can see this is the pipe, this is the clamp support, plain clamp support. This clamp is a primary one, primary support. Where the clamp is located on the I-beam, this I-beam is called as a secondary support. On the other hand, if you look for a pump is the load. Actually, pump with the motor is a load. Pump is located on the base frame. That base frame is the primary support which is support the pump. That pump base frame will be supported by the anchor bolt, anchor fasteners, or some other foundation bolt or grade where it is mounted. That is called secondary support. Same like for other equipments and pumps also. So what are all the standard types of pipe support? Generally we are used in our industries, refineries or wherever, support all same. So first we are going to see these are all the types of supports. Generally this is the types of support. First one is shoe support, saddle support, clamp support, U-bolt, wear pad, trunnion, spring support, hanging support, guide support, pipe guide support, limit stop, and anchor. One by one we are going to see in detail. So shoe support. First we have seen, we are going to see the type of one of the support. It's called shoe support. The name why it is called shoe support means, this is the reason. Here if you see, this is the pipe. Okay, but like a shoe, it is support the pipe from the secondary support. It is fabricated. It is a kind of fabricated support that is directly welded to the pipe underside, which rests on the supporting structure. This I-shaped is there. This is the we will cut from the normally we cut from the I-beam. This will be located. It will be rested on the secondary support, and the other end of this support will be directly welded with the pipe, fillet weld. This is the cross-sectional view. You can see here. Here we will do the continuous welding according to the diameter of the pipe, according to the load of the pipe. We will design this kind of support. Usually an I-beam is cut into two halves, is used as a shoe. You see here, this is a shape now. We normally we will cut from the I-beam. Generally, I-beam is a ready-made support structure. It is available in different sizes. Based on the load, based on the diameter of the pipe, we will choose the I-beam. The height of the shoe depends on the thickness of the insulation. Yes, this is the height of the shoe. If the insulation thickness is based on the temperature, the insulation will vary. If it is a 50 mm or 100 mm, accordingly, this height also will vary. So you cannot directly rest the insulated pipes on the secondary supporting structure. For those kind of areas, we need these kind of shoe supports. And what is the function? It allows the pipe to move in axial and transverse direction, but only restricts vertical downward movement. That means this is the axial direction. It will allow the pipe to move freely in the axial direction, also in the transverse direction, but only it will restrict in the downward. The pipe will not move the downward because it is rest on the supporting structure. So these are all the shoe support. Functions is used to move axial and transverse direction both. Wherever the insulation is coming, we will prefer this kind of shoe support only. Generally for steam lines or high temperature crude lines. And the next one is saddle support. You can see the picture. This is a saddle support. These types of support is generally used for large diameter pipes. and equipments that cannot be directly rested on the pipe rack. It is a shop fabricated shoe. It is a kind of shoe because it is some length is height is there. No? So it's a kind of shoe support, but it is a saddle support, another name. This is will be comes with the base plate with the same material which is welded to the pipe. Mostly it will be used in the large diameter pipes, as well as the any smaller equipments. Here it is. This is a saddle support. Here you can see the exchanger. This exchanger may be a diameter of 12 inch or 14 inch. Those kind of smaller equipments or any horizontal vessels will be supported by this type of saddle support. Saddle support will carry a high load carrying capability. They are quite popular to use as a equipment saddles. They are widely used for supporting horizontal vessels and heat exchangers. You can see this is kind of heat exchanger. The saddle supports are used here. Generally, these horizontal vessels and heat exchangers are supported by two saddles. One saddle is fixed and other one has a fixed anchor. Here you can see we may have mentioned here. This one is a fixed support. This one is a sliding support or movable support. Nothing but that hole will be vary. I will explain later. This why we are giving here sliding support means if it is a high temperature service, this exchanger will try to expand because of the temperature, the thermal expansion. So we have to allow those expansion. Otherwise, what will happen? Weld material may get distortion. That's why we are giving one support as a fixed one and another side as a sliding support. Sliding support is, you can see here, a fixed support means it is a hole, it is a fixed hole. For example, if we are putting M20 bolt net, that hole will be M22. Here also that M22 size will be here, but there will be a slotted hole. So based on the slotted hole, it can move here and there. So this is the difference between the fixed support and the sliding support. It will allow the exchanger or vessel to move according to the thermal expansion. So these areas only we are using this kind of saddle support. The third one, first we have seen the piping, shoe support, generally used for insulation pipes, insulator pipes. Second, we have seen saddle support, mostly it will be used for the larger diameter pipes and as well as the horizontal mounted equipments. The third one, we are going to see the clamp support. This is the clamp support. You can see, obviously we have seen, most of the people have seen, this is a clamp support. It is generally used to support the non-metallic piping. Okay, wherever the welding is not possible, wherever the non-metallic pipes are coming, like brass pipes, copper pipes, or PVC pipes, in a residential building or public places, you have seen these kind of clamp supports. For PVC pipe, HDPE pipe, these kind of supports only we are using. Generally, it is used for the low temperature, cooling water, raw water, utility air, service air, those kind of areas, we will use this clamp support. Fourth one is U-bolt support. This is another kind of clamp support only, but it will be used for both metallic and non-metallic. This one is preferably for low bore pipelines. You can see up to 2 inch we can use this kind of U-bolt. More than that sizes, this U-clamp will not be effective because of this arrangement. These U-bolt are available ready-made. It is available in market. So based on the requirement, we can get the U-bolt, because if you are going to put for use for 1 inch pipe means, if you ask for 1 inch size U-bolt means it is readily available according to the OD of the 1 inch pipe. OD of the 1 inch pipe is 33 mm. So based on that, this U-bolt is ready-made, it is available, no need to fabricate. But rather than that saddle support and shoe support and all, we have to fabricate according to our requirement. So here you can see some PTFE lining or rubber lining. Based on our requirement, it will be available, because to metal, because this GI bolt will come under, comes in a carbon steel or a GI galvanized iron bolt. If you contact directly to the pipe, there will be some galvanic correction will happen. So to prevent that, we will provide the PTFE lining bolt or rubber lining bolt. Based on our requirement, it is available. Other one is a wear pad. This is nothing but a simple plate. We will weld it to the bottom of the pipe. Why it is required means, wherever the rest support is coming. Later we are going to see the type of support also. According to the requirement. This kind of support is generally used for the rest support, because if you directly mount this is generally used for the non-insulated pipelines, cold service pipelines. If you load the pipe on directly on the secondary support structure, the pipe may get wear and tear, and because of the sliding, and also these pipe to secondary support, there will be water stagnation will be there. Based on that, corrosion will happen. So to prevent that, we will provide the same material. We will provide the wear pads, that is sacrificing like element, sacrificing metal. It will support the pipe and to the support secondary support structure. A Trunnion support or dummy support. This kind of support is directly welded to the main pipe. This kind of support we will provide for a larger size of pipes. Generally for air lines, that is called vapor lines, we will use this kind of dummy support. It is used to support both horizontal and vertical lines. Here we see horizontal lines and vertical lines also. We can use this kind of support. This will be welded in pipeline also. It will be welded from the bottom support also. It will be welded like anchor support. And another one special type is spring support. These kind of supports preferably used for where the thermal expansion and vibration expectation is very high. Like a sudden expansion will happen at any time, or if it is a turbulent flow, we are expecting in that pipeline. So those kind of areas we need this kind of spring support. Wherever the guide support and the shoe support we cannot use, those areas we have to use this kind of spring support. I will explain here. This is the spring support. This will be a kind of box. This is a spring containing box. Inside the box there will be a spring arrangement. Like in our two-wheeler, we are having a shock absorber. Same the kind of arrangement will be inside. So based on the flow, it will be the shock load will be absorbed by the spring, and this base load will be bolted to the secondary structure. It may be a concrete foundation or it may be a structural pipe rack. It will be bolted to that, and this spring inside the spring will take over the shock load due to the vapor from the pipelines. Mostly it will be used for the large diameter pipelines and the steam pipelines. They are using this kind of spring support. Another one is a hanger support. The name itself, why it is coming, it is a hanging support. Wherever these types of support is suspended from the structure or a concrete beam, the support height can be adjusted with the help of a turnbuckle or by adjusting the spring. Spring support also available with the hanging arrangement, and this kind of fixed support also will be available by the hanger support method. Here you can see now this is the turnbuckle. Here one will be a stud will be here. Here another stud will be there. Based on the pipeline height, we can adjust this turnbuckle and we can locate the pipeline. So this kind of hanger support will be preferred where the bottom support, it is not no space will be there, but we need a more manned areas, or more space is required for the maintenance type. Those kind of areas we can go for this kind of hanging support. This is the guide support. This function of this guide is to allow the pipe movement in predetermined direction. Like shoe support we have seen, it will allow the pipe to expand according to the thermal expansion or movement, but it will not guide. It will be freely allow the pipe wherever the pipe want to move, except the downward. And then after that we have seen some saddle support, that also will be a fixed support. But this guide support is also allowing a pipe to move along its length but not sideways. Here you can see these are all it's a permanent welded angle. This is the secondary support. This will be permanent, and then this is the pipe. This will be a shoe. Before we have seen that shoe that without guide. Here we are seeing the shoe support with the guide arrangement. This will be mostly this will be angle or a plate. We will weld this plate will be, or this angle will be welded to the support structure. Here we will maintain, generally we will maintain from this support to this support 3 mm, and here also we will maintain 3 mm. So we will allow the pipe to move transversely this side, and also some areas we will use this vertically, we can allow freely, we can allow. In this support you can see here 3 mm, here also we have guided this one, here also 3 mm we will maintain. So axially also, vertically also we will allow the pipe to move only 3 mm only. This guide is also used to restrict the vertical movement of the pipe depend upon the type of selection, because in by stress analysis or from based on the support, or if any expansion bellow is fixed in the pipeline, we will go for this kind of guided support, because some part only we can allow the pipe to move, because if you freely allowable, it will damage the connected nozzles of the rotating equipment or static equipment. Let's say the pipe is connected with the one pressure vessel or connected with the any pump discharge nozzle. If you freely allow the pipe, what will happen? The pipe will try to move away from the location, and unnecessary load will happen on the pump nozzle or pressure vessel nozzles. Those over the long period will damage the weldment of the nozzle. So to avoid that, we will provide this kind of guide support. And then limit support. This is also a kind of guide support, but arrangement will be differ. This is the permanent structure, this I-beam. This is the pipe, and the bottom one we have welded that wear pad, or this is a RF pad. We will weld the doubler plate. We will weld it. In that we will weld one angle or channel. So here we will maintain the 3 mm gap. So this pipe will not move more than the 3 mm this direction as well as this direction. This is called limit stop. Same time, one thing we have to keep in mind, we have to restrict the pipeline, but not too much. And at the same time also, we have to allow the pipeline and not too much. Based on the thermal expansion, based on our stress analysis calculation, we have to choose this kind of support and how much we can allow. If you allow more, also will damage the nozzle. If you anchor or provide the fixed support, also will damage the piping weldment. So we have to keep in mind while selecting the piping support. And then final one is the anchor support. Anchor support, the name itself is telling we will anchor the pipeline. So this one here also we will weld it with the pipe, and the bottom also we will weld the pipe. So in this area, the name itself suggests an anchor restrict the all three types of movement in a pipeline at a given point. So on three dimensional, we will not allow the pipe to move. So where we will prefer these kind of things, now there will be a permanent flange to flange is there. We don't want, it is not directly connected to the any equipment, or if any dead end point is there, those areas we will choose this kind of anchor support. Mostly in cold service pipelines, like very low temperature pipelines, we will go for this kind of anchor support. Or if any one side we may fix the expansion below, other side we have to anchor the pipeline. So those areas we will go for this kind of anchor support. So first we have seen the shoe support, saddle support, U-clamp, plain clamp. After that, anchor support, guide support. These are all we have seen. These are all the types of support. I mean arrangement structure. What are all the support element? So what are all the element we are using in the support, pipe support? So angle is a ready-made angle. It is available. Guide support and all, we will go for the angle. And then channel, where heavy load pipes and all is there. Next size is channel. And then next, if it is a higher size, I-beam, kind of a saddle support or shoe support, we will go for the I-beam. This I-beam we can cut into half. We can use as a piping support for the shoe support. And then springs. I have seen the spring-loaded support pipe. Those kind of areas we go for the spring. And then plate, obviously, we use the saddle support or base plate. We will go for the plate. And then pipes like Trunnion support, dummy support, and then guide support will go for this kind of pipe, because these are all the ready-made items which is readily available. If you go for a special item, means it may cost you more, and the fabrication time and the finally your project time also will go high. These are all the ready-made. We have to, while designing the pipe support, we have to think these are all the items we have accordingly we have to design the piping support or fabrication drawings. And then tie rod is nothing but kind of a stud bolt arrangement. We can adjust according to the pipe load or the initial position. And then turnbuckle, we have already seen in the pipe hanging support, a turnbuckle will be there. Turnbuckle you can see in many areas, like transportation and all, they will fix the object in a truck. They use the turnbuckle, because while movement it may get loosened. Again we have to tight. So periodically you can check, and you can check the tightness of the object. So the same like that, in any shutdown or any preventive maintenance of the support or any high road test you are going to do, that time you can check the turnbuckle arrangement, tightness, looseness in the pipe support. And then what are all the documents or what are all the things required for the support design? First one is pipe support standard you need, that we are going to see in upcoming slides. And the pipe sizes is the first thing. A construction material, whether it's a carbon steel or stainless steel or alloy steel or is a non-metallic pipe, you have to consider. A third one is insulation thickness, because based on the insulation thickness only, your shoe support thickness. Sorry, 1 second. Okay, based on the insulation thickness only, your height of the shoe and the support load, because the insulation is going to add the load on your self weight pipe. So that one you have to consider. And then is operating temperature and pressure, and then hydro testing. This one is very important, because we will design the initially we will design the pipe support based on the operating pressure only. But sometime after the installation, we need to do the hydro test, so the pressure will get vary. So we have to consider that safety factor while designing the piping support. And then the piping general arrangement and structural drawings, list of valves and specialty items with weight. As I said earlier, if it is we need to consider the dead weight, that number of fittings, approximately the number of fittings, and the valves which are going to mount on the pipe. That also we need to consider. If it is a small bore, smaller size means there will not be any much deviation in your pipe support. If it is a gate valve, globe valve compared to needle valve, it weight will be vary. So based on that, you have to consider the pipe support. And then list of equipment connection. What all the equipment is going to connect, whether it is a static equipment or rotary equipment. If it is a rotary equipment, you have to consider about the vibration and the thermal expansion connected to that equipment. So these are all the things you need to consider while designing the piping support. And then things to remember while choosing the support. Because you cannot design a very complicated, go for the fabrication drawing, because you have to keep it straight and simple, keep it structure simple. Structure simple means we have to design accordingly the drawing, fabrication drawing based on the available structures. You cannot design any irregular shape. Based on the ready-made shape, if it is designed, it will be easier for the fabrication. And then keep its specification simple, standard, same size. Mostly we have to fix the number of sizes for the whole project. So you cannot, for a 1.5 inch and 2 inch, you cannot go for the different size of pipe support. We have to give from let's say 1/2 inch to 1 inch. These types of size and dimension of the support is fixed. From 2 inch to 4 inch, these types of dimension support is fixed. So based on that, we can minimize the fabrication of the piping support. If you keep on designing different fabrication drawing for different sizes, it will cost you more and the time also goes high. So keep it site suitable. Basically, you have to consider the site where we are going to mount. That also we have to consider while choosing the support. And then pipe support span. So where we have to give the pipe support. So what are the factors means to distance, that pipe support means nothing but distance between the support. That is called pipe support span. Overdoing can impact your budget and underdoing impact your plant safety. This is the main thing, because if we keep on frequently we're giving the support, it may cost you the budget time wise and cost wise, and the underdoing also impact the pipeline and plant safety. So by deciding the proper support, pipe support, the following should be considered. Weight, what is the handling, liquid, fluid, gas or liquid. Accordingly, you have to choose the pipe support span. And then material. For carbon steel and stainless steel, there will be a different in strength, as well as the copper or non-metallic pipelines. For the non-metallic pipelines, you have to give continuous support with the angle arrangement or with any continuous U-clamp arrangement. For the material like carbon steel, based on the thickness, you can go for a longer span, let's say 2 meter or 3 meter. And then based on the insulation, if it is non-insulated, you can go for some distance. If it is insulated, the distance will be very less. And the nearby structural support, a point of concentrated load such as walls. If any walls is there, you have to place the support close to the wall or close to any other equipment which is supported on the pipeline. Like let's say if strainer is there, we have to give support the give the support close to the strainer or valves. So like that, operating condition, equipment conditions such as pump or reciprocating compressor, a maximum allowable deflection, those kind of things you have to consider while designing the pipe support span. There will be a thumb rule is there for the piping spacing rules. Like span, there will be a distance between the center to center of the pipe. Even if there is no flange in a pipe rack, a spacing should be based on a consider some factor. This is one pipe. This is a bigger size pipe. This is smaller than a smaller size pipe compared to this one. This one is going on the pipe rack. So center to distance, on what basis you have to design means, even though there is mostly in pipe rack, there will not be any flanges or any valves because of the leakage issue and the approachability. There will not be any flanges mostly. If it is a chemical line, where the possibility of choking issue, they will provide the break of flange. Otherwise, there will not be any flange. Even though how to calculate means between the distance between these two pipes means half OD of a flange, which is larger between the two pipes. This flange dimension we know plus half OD of the other pipe. This smaller pipe OD, half of the OD of the pipe plus insulation thickness of both pipes. If both pipe is insulated, mostly if streamline is going nearby, another streamline will be preferably it will go. So those thickness of the insulation you have to consider plus extra 25 mm you have to consider while laying the pipes, because this if you are going to provide a pipes shoe support at the pipe rack, so it will be easier. Here also shoe support will come because this is a insulated pipe. This is also insulated pipe, so here also shoe support will come. So we have to consider while choosing a space between the pipe. So these are all the things will affect the piping layout in the pipe rack. And then these are all the standard available for pipe support design. Here MSS SP58 metal design of pipe support, 69, 89, and then obviously 31.1 for power plant piping. ASME 31.3 is for process piping. These are all the standard available. You can get some piping support details, some standard details you can get from these kind of standards. And then these are the span chart for the piping support. Here you can see as per ASME B31.3 process piping for 1 inch size. If it is a water service, the suggested maximum span for straight horizontal length is 2.1 meter. Up to 2.1 meter for 1 inch pipeline, there will be without support. This is a support to support distance 2.1. If it is a vapor phase means there will be a 2.7. You can go for 2.7 based on the sizes, based on the service. The support to support distance will be get varied. Based on that, we have to provide the structural member. If it is pipe rack, then normally any pipe rack in India, normally in pipe rack, it will be 6 meter to 6 meter. Distance would be the main support. I'm telling. In the 6 meter, there will be every 2 meter, every 3 meter, there will be another one horizontal support will be there. So that one we have to consider while go for the piping support. What are the larger dia pipes? There will be a piping support will differ. Wherever the lesser dia pipes, we have to go for the distance between the support will be very less. Accordingly, you have to design your pipe rack. So there will be pipe rack. There will be a 3-tier, 4-tier pipe rack will be there. Obviously, that the loader, I mean higher diameter pipe will be at the bottom of the one. There you can go for the different types of distance between the support. And the top tier, we can go for the low bore line pipeline means there you have to go for the a number of supports will be increased because a smaller bore dia material pipelines require more supports compared to the large bore. So that is the span chart here it is showing. You can go through the chart later. And then common piping support rules. There will be a common piping support rules, not when it is if it is a critical lines means the support location usually decided by the piping engineers. The type of support is decided by the stress analysis engineer. So in upcoming training session, you are going to see detail. You are going to see about the stress analysis. From the stress analysis, we will come to know what are the types of support we can provide at the, whether it is anchor support or guide support. We will decide based on the stress analysis report. And then supporting for non-critical, it's a support span, guide span, and then concentrated loads, valves and the instruments. Based on this, we can go decide the requirement of support for the critical and non-critical pipelines. And then for supporting, first we have seen critical, non-critical. Here it is insulated and non-insulated. So supporting for insulated pipe means no direct resting piping to be provided. For insulated piping, it directly cannot rest on the supporting member. So insulation is there. Obviously, we need for the piping support. And then minimum clearance between the insulation and the supporting structure, that is a secondary structure, shall be minimum 2 inch, that is 50 mm. And then supporting of non-insulated pipes like cooling water pipelines, air lines, low temperature pipelines. So here will be directly rested, except the following pipes with the larger 600 diameter. You need them. Wear support, carbon steel with less than schedule 20, stainless steel less than schedule 10. These are all the non-insulated pipelines you have to consider while choosing the piping support. And then here the most important is the pipes that requires a slope and then dissimilar material to avoid corrosion, because supporting member mostly will be a carbon steel. But if you are laying a stainless steel pipe, you cannot directly lay the stainless steel pipe on the carbon steel. Because of the dissimilar material, there will be a corrosion. Even though stainless steel, it is not corroded, but it is contact with the carbon steel. Over the period of time, there will be if it is a water stagnation, it will corrode the stainless steel pipes also. So you have to provide the bottom plate, pad plate, wear plate in the stainless steel material, and then you have to load on the carbon steel pipe rack, so that you can save your lifetime of your pipe. And then the pipe that requires a slope. If the pipe is require a slope, if it is a flare line, if it is a drain line, means in piping support itself, we have to support height of the support will be vary towards the flow, and then we have to provide the slope. So these are all the isometric symbols we are using for the piping supports. For your understanding, here it is the we have already seen anchor support, rest support, guide support, line stop, and then rest and guide is there. Now these are all the symbols, legend symbols we are showing in the isometric drawing for the understanding. Last time we have discussed in previous training, we have discussed about the isometric drawing. In the isometric drawing, they will provide the which one is field joint, which one is sharp joint, which one is flange joint, which one is weldable, which one is same like that, which is the type of support also they will mention. In that isometric also like this. Like this, they will mention the pipe support like SPS1. If you go for this detail, now it will be available. This kind of legend will show the guide support. If any, this kind of into mark will be there. Those kind of support is called anchor support. So from the isometric itself, you came to know which support you have to provide. So while checking at the site with the isometric drawing, you can easily understand. So proper support is provided or not. So though for this purpose only, we are providing at the isometric drawing. This is anchor support, that means fixed support. Here rest support. Rest support is nothing but that wear pad we have seen. It will not guide, it will not restrict, it will not do anything. Just it hold the pipe. And then guide support. Guide support we already seen. It will guide the support in axial direction, both direction, but to the some limited extension only. It will guide the support. And then line stop. We already seen that that picture. It is also similar to the guide support. So these are all the symbols we are using at the here. The different symbol is there. Hold down, guide support, line stop. Based on the requirement, some legend is there. And then how are pipe supports shown in the drawing? From the isometric drawing itself, we can came to know what are all the supports we have provided. So compare with the piping layout and compare at the site, the isometric drawing, you can easily came to know the piping support type. These all supports are guide support. Here also guide, here also guide. Somewhere there will be a fixed one. So these pipelines are allowable to move some extent, some that 3 mm gap. So thank you. These are all the points we have covered from the today's topic. If any question is there, we can go for a question and answer. Thank you all. Thank you one and all.
Thank you, Mr. Chandramohan. Thank you for such an inspiring session. Thank you. We have received few questions in the Slido link we provided. Participants, if you have any further queries, please post in the Slido link or else in the chat box. Now we can proceed with the first question. What is meant by anchoring pipe?
Uh, just now we have explained anchor is nothing but is a fixed point, like name itself telling us it is an anchor because it is a three-dimensional stopper. It will not allow the pipe to move in any direction. That is called anchor. Like in a ship we are anchoring now, so it will not allow the ship to move. So that is the type of support. It will fix the pipeline with the supporting element. That's it.
Okay. How does safety valve discharge put a different load than that of normal flow pressure?
Sorry, madam, come again. Not clear.
How does safety valve discharge put a different load than that of normal flow pressure?
Okay. Like you know that same like a Newton third law, for every action there is always an opposite and equal reaction. So same like that, if it will be, there will not be any problem in the pipeline. If the steady flow is there, there will not be any issue. Suddenly if the pressure inside the pipeline, if it is increases, what the safety valve will do, it will pop up the pressure to the atmosphere. So if suddenly pop up, because safety valve will not, slowly it will not open. Once the set point pressure is reached, suddenly it will open and it will release the huge amount of fluid to the atmosphere. So suddenly there will be a vibration, so back pressure will happen in the pipe. So those kind of shock loads we have to consider while designing the pipe support. That's a different, the load will be provided by the safety valve to the pipeline according to the pipe support.
Okay. What is sagging?
Sagging means it is a distortion. Like sagging, it's a general thing. Sagging means without pipe, if okay, if you take a rubber or plastic pipe, if you can't give the continuous support, what will happen, it will deviate from the sagging. That is called sagging. It's a general common word, sagging. There is no technical. Everywhere we are using sagging.
Okay. Why is there a need of classification of secondary load? Can't it be classified under vocational load as well? In short, what is the basis of this classification?
Vocational, yes, it's a good question only. Secondary load we will calculate because based on the thermal expansion. Because occasional load is wind, seismic, earthing load. It may, when it will happen, we don't know. But if it needs a secondary load due to the thermal expansion, we obviously we will know it is going to happen. So that is a basic difference. But we just, it's a classification only. There is not much difference.
Okay. Non-critical and critical support.
There is no critical, non-critical support. Based on the pipelines only, we are defining the critical pipelines and the non-critical pipelines. If it is a high temperature service, high crude service, we will call it as a critical pipelines. So those kind of, there is no critical support and non-critical. Only pipeline only is there. So let's say if it's a high temperature, like super saturated steam we are handling, or high pressure more than 50 bar, 100 bars, or whatever the lines connected with the boiler feed water. So those kind of things, those kind of service or lines will comes under the critical pipelines. Generally, client will give us, or we will decide based on the operating condition, we will decide the critical and non-critical pipelines. Accordingly, the support will vary. That means what type of support we are going to provide. If it is a guide support or is going to be a resist support, based on that only we will vary. Critical, non-critical support only depends upon the critical pipelines and the non-critical pipelines only.
Okay. Why do we give slope for flare line?
So to slope means it will towards the knockout drum. There will be the flare, there will be a knockout drum will be there. If there is any, because in pressure, in flare line, it is not only connected to the vapor service, also it will connected to the some liquid service also. So whenever the liquid is carry over to the flare header, it has to goes to the knockout drum. If it is keep on stagnant in the pipeline, it will, because in flare line, like other lines, there will not be a frequent fluid movement in a pipeline. For compared to the cooling water service, there is always will be circulation. If it is a fire water, it is also will be under a circulation. But flare line, there will be a one end only, so it has to connect it to the other end. So to avoid the stagnant corrosion, pitting corrosion, it has to move towards the knockout drum. So that's why we need to maintain the slope in the flare line. So it will connect to the knockout drum. From the knockout drum, we will collect the water, wastage.
When selecting material for rest support for a stainless steel pipe, what will be considered so it doesn't cause rusting and other associated problems?
Rest support for stainless steel means we have to put the support as the same as the piping material. If it is a stainless steel pipe, we have to provide the pad plate. Only thing. Okay, for example, if you are giving a rest support or you are giving a even shoe support also for a stainless steel pipe, because some boiler feed water, some thermal plant and all, if it be 100 degrees Celsius boiler feed water pipeline, they are using a stainless steel pipe because to avoid the corrosion, because it may carry over to the boiler and finally it is going to the turbine, so it may damage the turbine blades. So they will provide stainless steel pipe there also. So those kind of areas, what they will do, stainless steel pipe bottom they will put the pad plate in the same material, stainless steel material only, and then bottom of that only they will weld the carbon steel shoe support. So if there is any corrosion, galvanic corrosion, any corrosion between the carbon steel, it will damage the only wear plate, not the parent material. So if any damage is there, we can remove that carbon steel and we can build another support. So it will not damage the parent material. So that is we have to provide the same MOC of the pipe.
Okay. Does flare line come under critical piping?
Yes, it is according to the client, because wherever we are handling the toxic corrosive fluids, there it will be a critical pipelines. If it is a handling normal, means it will not be toxic or corrosive, there will be non-critical. It is according to the client based on their previous experience in their service. So it is purely on the client call. Some areas we have seen some client from 6 inch and above flare lines, they will called as a listed out as a critical, and then less than 4 inch and less than that they call it as a non-critical. It is purely based on client.
Okay, these are the questions we received in this link we provided. Participants, if you have any further questions, you can unmute yourself and ask, or else you can post it in the chat box.
Hello, sir.
Hi.
Sir, I wanted to ask if there is some liquid fluid in the flare line, but during my one internship, I saw that I observed the knockout drum obviously before the flare line, but I also saw that the flare line, when turning on a pipe rack or stack, it turned upwards and then it came downwards. So if there is a fluid in line, won't that fluid collect in those corners when the pipe is turning upwards before the knockout run?
Is there any drain point is not there?
No, sir. They are on the pipe rack. When
That
the
means
flare line is running towards the flare, obviously, then it is turning upwards and then
I understand. There will be a if the pipe is elevated, so the liquid in the bottom, lower elevation pipe, it will not carry over to the upper side. That is what your question. That means mostly your flare line header is connected to the only vapor phase. That means wherever the safety valve is mounted, that may be connected to the vapor phase only, not in the liquid mostly. Otherwise, they may not consider this much of this is allowable liquid only. It will be there, but it will be carry over to the knockout drum with the vapor pressure. That is what mostly it will be connected to the vapor phase, not in the liquid.
okay, sir, but it was a plant for the gas which was present was rich gas. So obviously there is always a chance of condensation when flowing through a flare line. So isn't it still risky, or is there any other reason?
No, there will be corrosion will be there, because we have seen in our plant also whenever mostly the flare line will be leaking. So that time we thought it was a vapor only, but always we have seen if it is leaking, some liquid droppage will be there. But mostly it will be carried out by the vapor. Mostly now will be there, but wherever possible we have to provide the slope, because even though the safety valve is connected to the vapor phase, or it is connected to the vapor phase area, there will be some carryover of the liquid will be carried because of the pop-up pressure. It will be carry some liquid in it, so it will be go with the vapor pressure. It has to go to the knockout drum, but sometime it will be some stagnation will be there. That's why periodically in shutdown they will we will drain that one to the nearby any collection part is there, we will drain it. That is the only way.
Okay, thank you, sir.
Okay.
If anyone else is having any other queries or doubts, you can raise your hand or else unmute yourself and ask. Hope we don't have any further questions for today. Thank you all the participants. Thank you, Mr. Chandramohan, for such a wonderful session and your patience for answering all the queries. Thank you. Tomorrow we will not be having any sessions. The next session will be on Wednesday. Assessment for today's session will be on Wednesday morning. We will be sharing the link by Wednesday morning 9 a.m. If there is any changes, we will keep you posted in the WhatsApp group we created, and also we send email to the registered email ID. Thank you. Thank you all for your participation. Thank you, Mr. Chandramohan. Thanks once again.
Thank you everyone.